Hello everyone, I am NSG Saranya, Assistant Professor, Mechanical Engineering Department, PVC Engineering College, Autonomous, Swadal Revu. I am going to deal with the subject Instrumentation and Control Systems. In the series of video lectures, today we are going to see the topic Measurement of Force. In this, we are going to cover the introduction and definitions related to force, explanation of instruments like elastic force meter, load cells like strain gauge, hydraulic, pneumatic. Means we will see the principal description and operation of these instruments. Now if you see, force is a physical fundamental quantity. It has to be measured for a number of applications and hence its measurement is very important. There are a number of devices to measure force. First we will see the terms related to the force. So how the force can be defined as, it is a mechanical quantity which changes or tends to change the motion or shape of a body to which it is applied. It is called as force. Now if you see the weight of a body is the force exerted on the body by the gravitational acceleration. Mass can be defined as, it is a large body of matter with no definite shape. If you see the relationship between force, weight and mass is the amount of weight in an object, whereas weight is the force exerted on an object by gravity. Now we will see the principle of elastic force meter, which is also called as proving ring. When a steel string is subjected to a force, that is tensile or compressive, across its diameter, it deflects. This deflection is proportional to the applied force when calibrated. So by the amount of force applied on the steel string will deflect. This deflection, if you calculated and if you calibrated, then you will get the amount of force applied on a steel string. So if you see the description of this elastic force meter, this is the steel string which is in the circular cross section, and external bosses are attached to the steel string on both sides, which were in the rectangular cross section, and there was a precision micrometer with one of its ends mounted on a vibrating reed. Now if you see the operation, the force to be measured is applied on the external bosses of the proving ring. Due to the applied force, this ring will deflect. This deflection of the ring is proportional to the applied force. So at this stage, means when the ring was deflected, this vibrating reed will vibrates. When the reed is vibrating, the micrometer wheel is turned until the micrometer contact moves forward and makes a noticeable damping of the vibrating reed. Now the micrometer reading is noted, which is a measure of the deflection of the ring. Means the deflection may be either elongation or compression. Now the device is calibrated to get a measure of force in terms of deflection of the proving ring. So this is the working of elastic force meter. Now we will see the strain gauge load cell. Before going to see the principle of strain gauge load cell, we will see some properties about strain gauge. Strain gauges are made up of piezo-resistance materials. So what are these piezo-resistance materials are? These have the piezo-resistivity property. So what is this piezo-resistivity is? There will be a change in the resistivity of a conductor when it is strained. Means whenever there was a change in dimensions in the strain gauge due to the applied force, there will be a change in resistance. So by measuring the change in resistance, we are going to calculate the respective measurement. So this is how strain gauges have the unique property. Now we will use these strain gauges in the measurement of force. If you see the principle, when a steel cylinder is subjected to a force, it tends to change in dimension. If these strain gauges are bonded to the steel cylinder, it will also changes the dimensions along with cylinder. So whenever there is a change in dimension, there will be a change in resistance. If you measure this change in resistance and calibrate, then you will get the measure of the applied force. This is the principle of strain gauge load cell. Now you will see the construction of the strain gauge load cell. So this is the cylinder made up of steel, and 4 strain gauges are mounted on the four sides of the cylinder. Those are R1, R4, R2 and R3. R1 and R4 are mounted on the cylinder along the direction of the applied load. So these are called as vertical gauges, and R2 and R3 are mounted right to the right angles of the gauges R1 and R4, and these are called as horizontal gauges. And these strain gauges are connected to the limbs of the Wheatstone bridge circuit. Now you will see the working of the strain gauge load cell. Initially, when there is no load on the steel cylinder, all the 4 gauges will have the same resistance. Means, see here, as there was no load, there will be no change in the dimension of the steel cylinder, and there will be no change in the dimensions of the strain gauge. So as there was no change in the dimensions, means there will be no amount of strain developed in the strain gauge, so the amount of change in resistance will be nil. Then the Wheatstone bridge circuit will be balanced, means the potential at terminals N and P are same, so the output voltage will be 0, means the Wheatstone bridge circuit is balanced. Now if you apply the load to be measured on the steel cylinder, so there will be change in dimensions of the cylinder. Due to this load, the vertical gauges R1 and R4 will undergo compression, means as they were undergoing the compression, there will be decrease in resistance. At the same time, horizontal gauges R2 and R3 will undergo tension, and there will be an increase in resistance. So you have to remember here, in the unit 4 we have seen, when there was a compression, there will be a decrease in resistance. When there will be an tension, there will be an increase in resistance. Thus, when strained, the resistance of the various gauges will change. Now the terminals N and P will be at different potential, means the galvanometer reading will differs. So that change in output voltage due to the applied force becomes a measure of the applied load, means applied force when calibrated. This is how strain gauge load cell will works. And we have to remember that strain gauge load cell are used when the load is not steady, and the strain gauge load cell are used in vehicle weigh bridges and tool force dynamometers. Now you will see the working of hydraulic load cell. So if you see the principle, when a force is applied on a liquid medium which was in a confined space, the pressure of the liquid increases. Means the increase in pressure of the liquid is proportional to the applied force. Hence, a measure of the increase in pressure of the liquid becomes a measure of the applied force when calibrated. So this is how hydraulic load cell works on this principle. Now you will see, this is the diagram of the hydraulic load cell. If you see here, this is the diagram, the black portion, this is the diaphragm, and this was the piston with a loading platform placed on the top of the diaphragm, and a liquid medium which is under a preloaded pressure is on the other side of the diaphragm, and a pressure gauge connected to the liquid medium. Now we will see the operation of this hydraulic load cell. First, the force to be measured is applied on the piston. The applied force moves the piston downwards, and due to this, the diaphragm will deflect. This deflection of the diaphragm increases the pressure in the liquid medium. This increase in pressure in the liquid medium is proportional to the applied force. This increase in pressure is measured by using the pressure gauge which was connected to the liquid medium. The pressure is calibrated in force units, and hence the indication in the pressure gauge becomes a measure of the force applied on the piston. This is how hydraulic load cell will works. Now if you see, this hydraulic load cell is sensitive to pressure changes. So the load cell should be adjusted to 0 setting before using it to measure force. Next, we will see the pneumatic load cell. So the principle of pneumatic load cell is, if a force is applied to one side of a diaphragm and an air pressure is applied to other side, some particular value of pressure will be necessary to exactly balance the force. This pressure is proportional to the applied force. This principle can be easily understood by the operation of pneumatic load cell. So this is the diagram of pneumatic load cell. If you see here, this is corrugated diaphragm, and next see here, to the corrugated diaphragm a boss is attached, and an air supply regulator nozzle and a pressure gauge are arranged as shown in the figure, and there was an important part, a flapper was arranged to the boss. See here. Now if you see the working of the pneumatic load cell, the force to be measured is applied to the top side of the diaphragm. Due to this force, the diaphragm deflates and causes the flapper to shut off this nozzle opening. Now an air supply is provided at the bottom of the diaphragm. As the flapper closes the nozzle opening, a back pressure results underneath the diaphragm. This back pressure acts on the diaphragm, producing an upward force. Air pressure is regulated until the diaphragm returns to the preloaded position. How we will know that the diaphragm returns to the preloaded position? So see here, due to the deflection of the diaphragm, the flapper shuts the nozzle opening. When the diaphragm deflates to its original position, the flapper also moves to its original position and the air will comes out of the nozzle. So this is the indication that the diaphragm returns to its preloaded position. At this stage, corresponding pressure is to be noted by the pressure gauge. So this pressure becomes a measure of the applied force when calibrated. This is how pneumatic load cell will works. And see here, the accuracy of this pneumatic load cell is 0.5% of the full scale. So these are some of the instruments to measure the measurement of force. Thank you.